Alright, it's windy a little bit here. I'm trying to let this wind die down. I may do a little demo, or may do a couple of demonstrations. I see a discussion over there on the Friendly Metal Detecting Forum. Talking about this single frequency versus multi-frequency. You got one guy over there says single frequency is going to give the best performance, but the multi-frequency is more versatile. I don't really know what he's referring to. What does he mean by better performance? I mean, better performance on what? You talking about just for outright depth? Or what are you talking about? Here's a question for you to think about. Let's just take XP-2. If I sweep a dime at equal speed at 4.4 kilohertz over a clad dime, we sweep the call identically high, identically as fast as we do in 15 kilohertz. If we compare sweeping that detector in 4.4 kilohertz versus 15 kilohertz, which way does the processor on that machine, which one has processed the most information? Which one? You know, I think something's getting lost here and people don't quite get this. Look, and I ain't got no engineering degree, but I think I'm starting to, you know, my light bulbs, I think, is clicking, okay? It's on. You sweep a detector in hot or dirt. Now, there's a gentleman over there talking about that hot dirt. You sweep a detector in single frequency over that hot dirt. Not a real deep target. The detector does sound off on it. Oh, it says maybe it's iron, huh? So the detector is seeing that target. It's seeing that target. But not enough information. Not enough information. And lo and behold, you know, these grand engineers, you know, have figured this out. So if you mix the frequency, you get a comparison. And depending, you may actually, in that hot dirt, you get a comparison that would reflect what? Oh, that's a non-ferrous target. Yeah, you could sweep it in the lower single frequency or in the higher single frequency. And it not enough information. But when you have a multi-frequency, depending on the model, enough information comes through to what? At least, at the very least, call it a non-ferrous target versus single frequency. Now, it was reported early on, the old Equinox 800, you know, the Equinox 800, I guess the 600 falls into this too. It was deeper in the higher mineral ground versus the CTX. Well, why is that? Is it the frequency? Probably. I suspect it's the frequency that it's not necessarily the multi-IQ technology. I suspect it's the frequency. That's what I suspect. But I've heard talk about this FBS2, where they have this 25 kilohertz, you know, the second frequency, you know, where it's not the dominant frequency on that machine. It's sort of like it's there, but it's not as, you know, it's not used as much, maybe, I guess. So yeah, this best performance, I don't quite get that statement. You know, I can do a clear, simple test to show you that using, for example, 4.4 kilohertz is not going to be as good as a multi-frequency program using a DS2 even. And this wouldn't even be considered a deep target scenario. So, you know, everybody needs to remember this too. In and around iron, we tend to see single frequency machines. What were all these relic hunters hunting these high iron sites? What were they using to try to get the goods out of these sites? They weren't using 4, 5, and 6 and 7 kilohertz frequency units. They were using higher frequency units that were, more for the gold range. Well, what happens when you mix that up in a multi-frequency detector? So you have a frequency in that multi-frequency detector that, if it was a single frequency, it could see a non-ferrous target. It may not ID it, but it could see it. Same scenario, lower frequency won't see it. So that's what multi-frequency is allowing to happen. It's giving you the best of both worlds, meaning you're able to use a higher frequency, which works better around non-ferrous and iron in a lot of cases. And you're using a lower frequency, which, it's doing something. It's doing something. But using it by itself won't give enough information. It's basically there's not enough information given back to tell the owner, hey, non-ferrous target down there. So yeah, you take a single, you want to sweep around in a site using a 4, 5, 7 kilohertz single frequency machine, well, have a ball. Have a ball. Even in mild ground, have a ball. Because you're assuming every deep target, number one, has zero masking, I guess. That's what you're sort of assuming. There's no masking at all from anything. We're not even talking about hot dirt. Yeah, it's more versatile. That's correct. That part of your statement is correct. But the other part is, well, better performance with single frequency. Well, number one, you have to know what the target is. Well, what are you hunting? Yeah, that would help you. Yeah, deep silver, lower frequency, I get that part. But that's not going to bail you out of finding every deep silver coin. The E-Tracks and them CTXs were finding a lot of them coins they were finding back in the day, boys. They weren't finding that because they were running on, I think, 3.1 kilohertz single frequency necessarily. It wouldn't do that by itself. You notice there's not been a 3.1 kilohertz single frequency machine. I've not seen one. Well, if that's all it took, then why ain't we got one? Just be out there digging in them parks, digging them old deep silvers out. You wouldn't find a lot of them probably. That's just the way it is. That's why this, we heard this talk too about this Nexus machine, Well, where's the Nexus is at and where's the videos to support? I mean, yeah, it may unmask an iron, heavy iron calling out non-ferrous. It may do that. But then when you start getting into ID a target, which helps in some situations, that machine, that's a knob job detector. Well, I may do a demo or something just to show this, but I don't know quite what's going on. But when you're using multiple frequencies, the machine is getting more information, okay? There's more to compare to arrive at a conclusion, calculation. And this stuff about reactivity, well, you need to remember something too. Multi-frequency, I guess it's not as fast. Well, there's only one problem with that statement. Remember, if you start mixing low and high frequencies with a multi-frequency machine, it goes back to what did I say in the first part of this video? When you sweep over a target at 4.4 kilohertz compared to 15, at equal speeds, equal height above, let's just say a clad 9, the same call, which time did the detector process the most information? I say the 15 kilohertz. Because 15 kilohertz is faster than 4.4 kilohertz. So yeah, when you add a higher frequency to that 4.4 kilohertz, remember, they're switching. And you start talking about this, you mentioned this word reactivity. Well, the demo I may do may clear some of these up for folks.